One of the most common problems audio programming beginners experience is that they want to implement a Temposync feature, like a rhythmical LFO or a sequencer. But they don't know how to get started or suffer from inaccurate results they can't make sense of. That's why I decided to make this video, in which I show you the most basic example of a clean Temposync effect. I will use this plugin script patch to demonstrate the effect, but you can apply the same logic to all kinds of plugin development environments. The plugin outputs a ramp signal, which describes the phase within some musical time interval. The oscilloscope is always set to a quarter note in this video. On the interface, we can see the rate parameter is set to a 1/8 interval. That matches with the oscilloscope because 2/8 notes fit into 1 quarter note. This is the process block method of the effect. It describes what happens to the audio and MIDI information within a block. The user defines the maximum block size with their audio interface, but the length of each block can vary. Every plugin development environment gives you some way of gathering transport information, like the current position of the playhead measured in quarter notes, often called PPQ. In plugin script, you call transport get position in quarter notes on the input argument of the function, while in Juice you call get playhead to read the pointer to an audio playhead object, if the playhead exists. If we print the PPQ value to the interface, we can see a number constantly rising in value during playback, until the playhead loops back or playback stops. The integer of the PPQ value describes which musical interval came last, and the fraction describes how close we are to the next one. I multiply the PPQ with the rate parameter's value to change its speed, and fill the entire audio buffer with just a fraction of the PPQ. When I run this code, I can see a ramp that mostly describes the musical interval, but it's weirdly steppy and it measures the moment of the event inconsistently. When you turn up the rate, the error gets even worse. The reason for that is because the PPQ only represents the project position at the start of each block. The actual event of a musical interval in the project is more likely somewhere within the block. So you have to figure out a way to ramp up within a block so that it lines up with the upcoming PPQ value. This is the job of a phasor. A phasor has a phase which ramps up until it reaches 1, in which case it's flipped down close to 0 again. The phasor's speed depends on its increment value. This class synthesizes repeating normalized ramp signals. An object of it processes for every sample index, and then I write the phase value into the audio buffer. This fills the gaps in the signal and produces a perfect representation of the musical interval, but the phasor has to run at exactly the right speed for it to work. The speed depends on the BPM, the sample rate, and the rate parameter. First, you convert beats per minute to beats per second, because this describes how many quarter notes per second are played. You know that the sample rate represents exactly 1 second of samples, so the ratio between the BPS and the sample rate describes the increment value of a quarter note. Just like the PPQ, this value is being multiplied with a rate. Now that you can generate a signal that can run perfectly at any musical interval and is synchronized with the project's grid, you can implement any Temposync related feature you want. Like and subscribe my channel if you are in the mood for more audio programming stuff.